This is section 1.5 dealing with limits at infinity, and we'll be discussing various asymptotes both horizontally and vertically. We're going to kind of revisit just the basic idea, basic notion of what a limit is, and discuss what happens when you approach the same infinity. For part A, the limit as I approach -1. Now initially we said if we had an asymptote, the limit didn't exist, but we're going to kind of slightly change that, because I can discuss the behavior of a graph as long as it takes to take into the same infinity. So for part A, if I'm heading towards -1, both sides approach the same infinity, so I can designate this to be what the limit is. Now that doesn't mean that all of a sudden infinity is a numerical value, it's an answer. This just means that if it approaches the same infinity, I can talk about the end behavior as I'm approaching that value. For part B, as x approaches 2, again I have to be able to approach the same infinity, and as I go towards 2, this graph heads towards -infinity, so that's going to be my limit. For part C, I'm heading towards 5. The limit from the left takes me to infinity, the limit from the right takes me to a -infinity. They shoot off to different places, so this limit still does not exist. And the reason for this is because the limit from the left does not equal the limit from the right. The last two I'm going to be discussing is the limit as x approaches positive infinity. Now, as I head towards the right on this graph, this has a horizontal asymptote across at y equal to 1. So as x heads towards positive infinity, my limit, my asymptote, is going to equal 1. As this graph, I'm looking at it as x going towards -infinity. This is approaching, looks like the x-axis, which is going to equal 0. And that's it for example 1. Now example 2 deals with sketching a graph that has various conditions. At this point you should maybe pause it and see if you can come up with a sketch yourself, see if you can come up with something that satisfies all these conditions, and then see if it matches what I have. First thing I notice is that the limit going towards 1 has to equal 2. So I'm going to put an open circle at 1 and 2 and just kind of put two little lines to indicate the limit from both sides exists, and then maybe once I get some more information, connect the graph all together. Limit as x approaches 5 is infinity. So that means if I approach 5 from both sides, it's taking me towards infinity. Again, I don't really know what happens in between. Once I'm done with all this, I'll connect the graphs accordingly. Limit as x approaches -1 from the right takes me to -infinity. So if I approach -2 from the right, I have to shoot down towards infinity. If I approach -2 from the left, I have to shoot up towards positive infinity. As I approach now infinity, this has to shoot over to -1. So this has to maybe have a horizontal asymptote this way. Okay. As I approach -infinity, I'm heading over to 3. So -infinity this way takes me over to 3, so there's my other asymptote. And then now all I have to do is just connect this piece and this piece. So maybe I can draw this line going up this way and have an asymptote like that. Remember, this has a different infinity at -2, so I don't connect these two. This one and this one must be connected, so maybe I can draw and connect it this way. This one I can connect maybe just going across like this. This is a vertical asymptote at 5, so I don't connect these two. And then this piece and this piece have to be connected. So I can just maybe draw it going up like that. And hopefully tomorrow when I check your notes, maybe you guys had something similar to this, and we can maybe discuss why yours is a little bit different than mine, and maybe seeing if they are truly similar, or maybe they're way off. All right, the last thing for this part is going to be discussing vertical asymptotes. So vertical asymptotes are kind of like what we talked about over here, heading towards infinity or heading towards different infinities. But basic idea is that we're going to say the line, the vertical line, x is equal to a, is a vertical asymptote if, when you plug in this number, the expression gives you a number over 0. So, finding vertical asymptotes to the following, what I can do for this one is easily factor this as x minus 3 and x plus 3. I can factor this as x minus 3 and x plus 7. And then look at each individual factor and see what solves it. Well, if I plug in 3 to the top and the bottom, I'm going to end up, if I were to plug in 3, I'm going to end up with an indeterminate form, which is 0 over 0, which means the limit exists, but I'm looking for a vertical asymptote. I'm looking for something that gives me a number over 0. So x is equal to 3 is not what I'm looking for. The other thing that could make the denominator 0 is going to be negative 7. So at x equal to negative 7, well, if I plug in negative 7 into the top, it's definitely not going to give me 0. So it's going to give me some number. But if I plug in negative 7, it's going to give me 0. So there's going to be a vertical asymptote. I'm going to abbreviate VA at x is equal to negative 7. And that's kind of it. You go ahead and find what makes the denominator 0, and you test those points. So this made this part 0, the negative 7 made this part 0, and then you see if these two solutions give you 0 over 0, or they give you a number over 0. So the only vertical asymptote is going to be negative 7. But I want you guys to try on your own, and I'm going to be checking tomorrow, is this expression. So for this one, I want you guys to find the vertical asymptotes, and you should find 2 of them. And that's it for this video.